Okay, today I want to talk about transforming a step function. We looked at transformations previously. We talked about what the B, A, C, and D do to the function and where they are located actually in the equation. With a lot of our functions, we make tables of values, and then we actually perform some different operations with the x's and y values. With a step function, I find it easier to actually apply the transformations directly to the graph. And we can use a table as kind of a backup as a way to check our work. So let's start with what the basic parent function looks like. I've got a picture of, here's our basic step function or greatest integer function, and we can see in the picture what it looks like. And we know some of our basic transformations. So for example, if I wanted to, I'm just going to trace over this real quick in red. If I wanted to provide or make a couple of shifts to this graph, let's say that I added 3 to the end of the function, so this is my D value, and let's say that I subtracted 2 inside the grouping symbol, so that is my C value. Remember that these are shifts, so what this is going to do is shift the graph vertically by 3. So in other words, it's going to go up 3, and then it's going to shift the graph horizontally. However, remember that this one, we go the opposite. So this is going to shift horizontally, and that's going to move it to the right 2 units. So what we can do, since we know what the parent function already looks like, we can literally take that parent function, shift it up 1, 2, 3 places, shift it to the right 2 places, and there is our new function. Okay, these shifts are pretty easy. You can move the whole function all in one piece. If you're graphing this on paper, you might have to just shift each step in those directions. Let me do this again. It is the stretch and compressions that can get a little bit trickier with these step functions. So I want to talk for just a moment about what those actually do. Let's say that I multiplied my integer function by 2. Well, normally we would talk about this as being a vertical stretch by 2. Now, if we think about stretching out this graph vertically, what that's really going to do is separate the steps and increase the space in between each step. So the space between these steps will actually double in this case. So if we look at the original graph, we can see that the original function, there is one space in between each step. If I was to multiply the function by 2, then here would be my first step, nothing changes, but my second step would be 2 units above it. And then my third step would be 2 units above that, 2 units above that, 2 units above that, and it's stretching out the entire graph. So it's really about spacing it out differently. Now let's go back to what it would look like if we had a stretch or compression inside the grouping symbol. So let's say this time I did a 2 inside the grouping symbol. Well, what this is going to be is a horizontal, and then remember, because it's inside, since we're dealing with the x's, we're going to be doing the opposite. So this is actually going to be a horizontal compression by 1/2. We're not going to be doubling it. We're actually going to be compressing it by 1/2, okay? So what's that going to really look like? That means that each step is actually going to be 1/2 as long. So again, if we go back to our original function here, currently each of our steps, I'm going to zoom in a little bit, currently each of our steps is 1 unit long. Well, now our steps are going to be 1/2 unit long. The next step is going to be 1/2 unit long, the next step 1/2 unit long, and etc. So as you can see, we're kind of, compressing it, bringing them closer together, and still following it that way. Okay, so then the last thing we need to mention is what happens if we have reflections. Okay, if your function, your f of x, switch back to here. If your function had a negative, you were multiplying the integer function by a negative, what that's really doing is multiplying each of the y values by a negative. So that is going to reflect over the x-axis. Okay, we call that a vertical reflection. It's going to be reflecting up and down. So how would we graph that? Well, again, here would be our first step. Now, normally we would go above that and graph our second step right here, but because we're reflecting over the x-axis, our second step is actually going to be down here. And again, we're just going to keep drawing these steps down here, and of course we can have some the other way like this. So this would be a reflection over the x-axis. And one more, if we wanted to show a transformation where the negative was inside the integer function, what this will do is reflect it horizontally. So essentially, that is going to flip over the x-axis. So in this case, here would be my first step. Again, my first step normally shoots out to the right. If I'm reflecting over the x-axis, that step is actually going to be shooting out to the left. And then the next one above it, the next one above it, and I can keep going. So that's just that reflection over the, I said x-axis, I'm sorry, over the y-axis. Okay, so now we've got to put all of these different things together to actually graph some. Now, one thing I do want to remind you of when you are applying transformations, especially when you're doing it without a table, you do need to remember that your transformations do need to be applied in a certain order. So in other words, think about your order of operations. Think about your PEMDAS. Okay, we have to do any of our multiplication and division transformations first, and then we can do any of our addition and subtraction transformations second. So what that means is we're going to be doing any of our stretch and compressions first, and then we will do all of our shifts second. Okay, so as we look at this first example, let's talk about just the stretches and the compressions. The 2 outside the function, what that's going to do is stretch vertically by 2. Okay, well, what does this really mean on a step function? This means that the space between steps doubles. Okay, so that's the first thing. At the same time, let's talk about this 1/3. So this 1/3 is actually going to, we're going to essentially, multiply by 3. Remember that we do the opposite. And what is that actually doing in a step function? What that's doing is making each step 3 times as long. Okay, so let's do those 2 things first. We're going to make sure that each of our steps is 3 times as long, and we're going to double the space in between the steps. Okay, so my original step function would have been 1 unit long. I'm going to make this one 3 units long, and then my next step is going to be 2 above it. 3 units long, 2 above it, 3 units long. I can actually go down here and do that as well. So 3 units long, 2 below, 3 units long. And you want to get yourself, good 3, 4, 5 steps. Knowing, of course, that it does keep going. Now, once we've got the basics, now we can go back and now we can do our shifts. And in terms of our shifts, we are going to shift up 3 units, and we are going to shift right 1 unit. So now I'm going to take this whole graph and I'm going to shift it up 3 units and right 1 unit, and there's my function. Okay, remember the order is important as we're doing these. We'll look at one more quick example. This one I threw in a reflection. So once again, we do want to talk about any of the shifting, compressing, even reflecting. Those are all operations dealing with multiplication. So we're going to do all of those first. And what this is telling us here is that we're actually, this is basically like multiplying by 1/2. Remember, we're going to do the opposite. So what this is going to do is shrink the graph horizontally. Each step is half as long. So now we have little itty bitty steps. Okay, then this negative outside the function, this is going to reflect the graph. And since this is outside the function, it's affecting the y values, so it's reflecting it vertically. That means it's going to reflect over the x-axis. Okay, so let's plot those first. I'm going to zoom in a little bit because it's pretty small. So each step is half as long. So my first step, only half. Okay, now normally, again, I would have gone up and I would have made my second step right here. But because there's a reflection over the x-axis, my second step is going to be down below it. And then remember, each step is half as long. So, oops, so we've got a few steps in here. And again, you can kind of go the other direction as well and plot a couple of these guys in here too. Okay, back to our function. Now we can apply our shifts. This one is going to shift up 2 units and left 4 units. Remember, always go the opposite with the anything affecting the x values. So now if we go back to our function, we can drag this whole function. I already forgot. We're going to drag this function up 1, 2, and left 1, 2, 3, 4. And here's my new function.